Hi everyone, thanks for joining. Today I'm going to tell you about the journey of crafting and validating a disaster recovery plan for a startup with millions of end users. And the fact that you are here today actually may save a lot of money to your company if you will listen to the insights and the bottom lines of this talk. Before we start, I wanted to take a look on these dates, maybe tell something to someone of you. Actually, the last one is not so far. These are dates of AWS US East 1 outage in the last few years. You can see that from time to time, there are issues for very central services. It happens, and why it happens, many very famous services are down, but you don't have to be one of these services. When everyone down, you can not be down. How can you do it? If you are building a resilience architecture. Resiliency, following AWS documentation, means that it's the ability for a system to recover from a failure induced by load attacks and failures. And one of the biggest signs that your application is resilient if you have a DRP, disaster recovery plan. And this is going to be the topic of today. I want to present myself in a few words that regarding the workplace. Today I'm working in a small gaming startup, very fast-growing startup, pretty new company. This is not the company I'm going to talk about today. The case study that I will show you today is totally real. I actually did everything from a small startup that I worked until half a year ago, own ID, a passwordless authentication solution. Before to that, I was at WalkMe and at the IDF. And I'm an AWS community builder, solution architect, as I said, about the philosophy degree, and married and father of two. So from this talk, you can expect for common DRP concepts, because we must have a common language before we are starting to dive into the details. We will go through a real case study based on my method of DRP crafting, disaster recovery plan crafting, and we will walk through few possible architectures, and we will see the challenges, the decisions that I made, and few takeaways at the end. So I want you to have a context. Why was it so important to have a DRP? The solution of OwnID is a widget that you can integrate with an application, and it just provides a passwordless authentication. So it is actually the gateway to the website of our customers. So if it's down, it's really not good. The customers of our customers won't be able to log into the system. Now we will start to go over the 7 steps plan that actually after I finish the disaster recovery plan, I find out I can split it into 7 steps that will make it easy to understand. So step 1 is the BIA, the business impact analysis. Before you start and to talk about the technical aspect, you need to understand what you are willing to do. What is the disaster that you are willing to deal with? And every disaster has a different recovery. So for example, if you're afraid of a disaster that all your developers will lose internet connectivity. If you have a war in your country, it's possible sometimes the internet falls down, and then you may have a production incident, no developer can connect to handle it. So a recovery for this one can be to have a developer in another country that will be available all the time. You can have another disaster that someone takes over your AWS account, then a cyber attack, then you don't have access. And as I said, you need to have a defined disaster, a defined recovery. In the case study that I will focus today, I will talk about a region outage, something that we actually had and it affects us really bad. And the solution that I will describe is a multi-regional architecture that you will understand later if you're not familiar with this concept. Step 2, still before the technical part, you need to analyze the DRP ROI, the return of investment of the disaster recovery plan. Because you can spend the whole year building a disaster recovery plan, and you can also decide that you don't need to do it at all. It's really a decision that needs to be taken with all the stakeholders and the product guys, the developers, the technical guys. Everyone needs to sit together and discuss to understand what are going to be the costs for the disaster recovery plan and how much money it will save to the company. And only then, when you understand that you can move on and you can go to the next step, you need to translate all the business needs into technical implementation terms. And that's, on that point, we are going to talk about few really important terms. The most important terms in DRP are RPO and RTO. Recovery Point Objective talks about the past. How much data I'm going to lose. I can afford myself to lose if I have a disaster. It means how much time will you take me back? How back will you take me in time if I have an issue? I mean, you can take me 1 hour back, because if I have a database, I'm taking a backup every 1 hour, and then the disaster happened almost 1 hour after the backup. It means that once I restore the backup, I lost 1 hour. So this is an RPO of 60 minutes. And the RTO talks about the future. The future means how much time I want to afford the system to be down, how much time it will take until the system is live again. You need to have in mind that RTO and RPO, there's an inverse relationship between cost to RTO and RPO. The more money you invest in the disaster recovery plan, then you will have lower RTO and RPO. And we are going to see how exactly the cost effect on it. On our case at OwnID, we decided that we want RPO of 10 seconds and RTO of 20 minutes. Why we decided about 10 seconds? Because to have a real-time replication of the data to another region to always back up, it's something that's not really so realistic. So we decided to find a sweet spot. We are okay with losing around 10 seconds of data. It's not so expensive to have this replication. And we can live with that. And 20 minutes of downtime of RTO, how did we decide about 20 minutes? In our case, we have 3 nines availability SLA to our customers, which means around 44 minutes per month. And if you take into account around 2 incidents per month that you can afford to yourself, if you split 44 to 2, it's around 20 minutes. So that's how we came up with the decision of 20 minutes. It's not a golden rule, but I just want to show you a way. How can you calculate it? Just to everyone can find his way to calculate it. After we have the RTO and RPO, one more thing to consider is the possible architectures of the disaster recovery plan. Few terms that many people know are active-active and active-passive. And active-active is actually the most expensive architecture. It gives you around a real time of RPO and RTO, almost 0, but it's super expensive because it means that you have all the time, all your architecture, all the resources of application are live in full capacity, high resources all the time, and are ready to receive requests, and maybe they are even receiving requests all the time. Netflix, for example, they have active architecture. All the time they are running on 3 regions and receiving requests, and if you are a small startup or a company with few limitations of cost, like most of the companies, so maybe when you will have a disaster, you will survive it amazingly, but your bank account won't survive it. So most of the companies are not using the active approach. Active-passive, this is where most companies find themselves after all. The cheapest one is backup and restore, which means you're storing your data once every few minutes, few hours, your decision, and then once you have a disaster, you need to restore this data to the relevant region, and then create all the infrastructure around it, because you have only the data. This is the most important thing, and then you can run your Terraform script or create manually your environment from scratch. At OwnID, this was not relevant for us, because with 20 minutes of RTO that we defined, we can afford to ourselves. It used to take us like 1 day to create a new environment. This was half automatically, half manually, so it didn't fit. Pilot Light and Warm Standby are both pretty similar approaches in both architecture, you actually have in advanced all your architecture already made in the separated region, but in lower resources to save cost. In Pilot Light, you still need to perform few manual actions in order to make the environment ready to receive requests. Like, for example, you still need to, on our case, we still need to change a certificate on the CDN and make few manual steps. On warm standby, you don't need to do anything. It just works, and you just need to increase resources. So this is why the RPO is a bit better in warm standby, RTO and RPO. And at OwnID, we are somewhere between Pilot Light to warm standby, because as I said, we had few manual steps to do in order to apply the disaster recovery plan. I just asked myself if these manual steps will take more than 20 minutes or less than 20 minutes. And since it took much less than 20 minutes, I was okay with defining myself somewhere between Pilot Light to warm standby. This is our case. The next step, just before the implementation, it's important to filter out background noise. Like, maybe you don't want to put all your architecture as part of the disaster recovery plan. In our case, we have a BI screen inside the console for the customer, where you can see how many end users logged in and how they use the product. And behind the scenes, it uses an Elasticsearch and many components that in order to back up them, we had to pay a lot of money. So we just decided that it's okay that it won't work when there's a disaster, and we can leave it out of the picture. Just need to know about it and decide about it, and everyone knows, and then you prepare an error message which explains the situation to the customer. So after you filter out what you don't need, the implementation step. I'm going to show you now the architecture of the DRP. First, we start with the simple architecture of the product, and then I will show you how the disaster recovery plan combines with it. So we have an end user that accesses a DNS record. DNS record references the CDN, content delivery network. We are using it in order to improve performance, that end users will access our resources and load balancer faster. CDN has few origins. One of them is S3 buckets. S3 buckets is the storage blob service of AWS. I'm going to show now all the examples will be from AWS because this is our case, but all the other cloud vendors they have the equivalent services, okay? So there's the S3 buckets that we use to store JavaScript files and translations and things like that, and there's the API gateway. Behind the API gateway, we have Kubernetes cluster, and inside the Kubernetes, we have few services, and they access Postgres database, Redis, and the secrets manager. It's the secret service of AWS, and the IAM, the identity access management service of AWS, is running in the background to handle the permissions and user behind the scenes. So when I started to think about how am I going to build a disaster recovery plan for this architecture to make it multi-regional, to have a possibility to run the same application on another region, first I started to split the services to global services and regional services. There's a big difference between them. Global services are services that you can create an instance of them and you don't need to choose the region. The cloud vendor handles this for you behind the scenes. So the CDN, you can just create a CDN distribution and you don't choose the region. Regional services, you must choose the region and the cloud creates for you an instance of the service only on the region and it exists only there. So I started with the regional services and specifically with the stateful components where we have data because every time the data is the most complicated part of the disaster recovery plan. it's S3 buckets and all the databases, Redis, Postgres, and the secrets manager. First, Postgres. We are storing customers' data inside Postgres, not end users' data, but only the customers' data, the configurations of the applications that customers create. So what we did is a asynchronous replication. Every time someone writes something to the main replica of the database, there's an asynchronous replication to cross-region replication to the disaster recovery region. There's a small lag between when someone writes something until it's been replicated to the read replica. It's, according to AWS docs, it may take between few milliseconds to few seconds. And as you remember, we defined 10 seconds of RPO. Like we afford ourselves to lose 10 seconds of data, and it's good because it can't, unless there's an incident on AWS side with something specific with the replication, there shouldn't be any problem. Once there's an issue, the main region goes down, then we promote the read replica to be the main replica, and the main previous database is out of the picture, and now the read replica becomes writable. And then we, as I will show you now, we just need to craft all the environment around this database in the disaster recovery region. Secrets Manager we use the similar solution. We are storing systems data, secrets for Kubernetes and things like that. We just use a feature that AWS gives out of the box to replicate a secret between the regions. It's much simpler than the Postgres because you don't need to do anything. The secrets are always available for you in both regions. Static data that we store on S3 buckets, we use the similar approach. This data doesn't tend to change so much, only when we deploy new code and we update new translations. So we decided to make it as part of our deployment process. When you have new code or new translations, then we upload by ourselves everything into the 2 buckets that we have in both regions. We could use cross-region replica, but we decided to keep it simple on that case. I just wanted to show you that there are other approach, not just always use cross-region replica. You can also handle it manually, and there are many, many options to do it. On Redis, we store temporary data. End-user sessions, for example, the login process of an end user, on which step he is, the OTP code that he needs to receive to his phone, for example, and another type of data is the app configuration cache. We are just caching everything instead of accessing Postgres, you can access Redis to get it faster. So we decided not to backup Redis. This is also a possible decision in the DRP, not to store all your data. Why we are not storing all the data? End user sessions. Let's say after 20 minutes, the system is live again. The end user didn't wait for you. You lost him, so there's no point in restoring end user sessions. And the app configurations, in a few seconds, we can rehydrate everything from Postgres to Redis again. So it was really redundant to backup Redis. That's an example. Don't backup everything. Think before you backup. So these are the data components. Now I want to go back for a second to the global services. As I said, the cloud vendor needs to handle for you the resilience of the global services. So it's not always like that. Let me explain you one. We explain you why. We talked about the DNS record, like it's Route 53 service of AWS. CDN, it's CloudFront. That's the name of the CDN of AWS, and IAM. You would think that this is the architecture that I need to use because we have global services. Let's not duplicate them. They are always available. So in advanced, let's duplicate only the regional services because when I won't have them in region, I need to have them in advanced in the DR region. So this architecture actually is bad. It won't work. And to understand why, you need to be familiar with 2 concepts of the way that cloud manage services: control plane and data plane. It's a service that exists. These are two concepts that exist in many, many cloud services. Control plane is in charge of administrative APIs. For example, when you create a new S3 bucket, when you launch a new server, these are actions that are administrative and they are not tend to happen too much. Data plane, this is the component that handles the actions that happens all the time. When you send a query to the DNS and you get a request, and when you download the file for the S3, these are the regular actions of the services. The data plane is distributed. Every region has a data plane of itself, and the control plane, since it's doing much more complex actions, most of the cloud services, the big ones, have a control plane for each service only on one region. Also for global services, there is a control plane in one region. For CloudFront CDN, the control plane is on US East 1. So when US East 1 is down, the control plane of the CDN is down too. And what are the consequences? Let's say now the main region is down, and we want to switch the origin of the CDN from the main region to the disaster recovery region. It won't work because changing the origin of the CDN is an action that relies on the control plane. That's why the solution, one of the solutions, is to create in advance two CDNs, okay, which you configure before you have a disaster, each CDN to a different origin. One is for the DR and one for the main one. And then once you have a disaster, the switch will need to happen on the DNS level. And in the DNS, you have a feature, DNS failover, which relies on the data plane. This specific feature relies on data plane, and this is the right architecture to be prepared for a disaster, okay? So we handled some more components. Now I want to dive into other aspects of the DR. Terraform, for example, because we had an architecture which was, and all the resources were implemented with Terraform to automate the creation of the environment, and now we need to add the disaster recovery environment also to Terraform. When I came to create the disaster recovery environment in Terraform, I had in mind that I need to split my resources into three groups. The first one are resources that needs to be duplicated exactly as they are. For example, Kubernetes cluster, API gateway, S3 buckets, I need to have the same resource in every region, in the main region and the disaster recovery region. The second group are resources that needs to be duplicated, but with small tunings. For example, Postgres in the main region, it just exists with the main replica, and the disaster recovery region, it needs to exist as a read replica which reference the main one. And the third group is resources that doesn't need to be duplicated at all. For example, DNS records. We are using the same also to the DR and also to the main region. That's an example of a small tweak that I had to do in the code. I added a flag to the resource of the database because I wanted to use the same resource, the same module of the database, also for the main region, also for the DR region. So I added a small flag if it's a DR environment. If it's not, it's creating the main replica. And if it is the DR environment, then it applies the resources a bit different with the is replica true and the reference to the main database that it needs to know. We have many more examples that I will attach. You can find at the end of the conference a few links with many examples in a GitHub repository, okay? Another aspect that we need to know that during the disaster, you still want to be able to provide code, to deploy new code. So you still want to keep your CI/CD working while you have a disaster. You don't want to be stuck with the same code version. Maybe you have a bug during the disaster and you need to deploy new code. new code. That's an example from our GitHub Actions, the CD process. We are storing images on the ECR, the images registry service of AWS. So we had to have in mind to create another ECR instance because it's also a regional service. So you need to think also where you store your images. It needs to be available during the disaster if it's down. So we actually duplicated it. We created another one on the DR region. And also we have always two processes that are running in parallel that deploys every code into two environments. And if one of them fails, you have to write your code in a way that it won't roll back the other one, because that's all the idea. It needs to keep functioning when one of them is down. So we covered all the architecture, the interesting parts, the interesting challenges. Now a super important step that you need to have in mind is the execution plan. Because after all, probably there are high chances that you won't be the one that perform the disaster recovery plan. You may leave your workplace, then a new DevOps will come. Under fire, he will need to apply everything you had in mind. So what I did is actually, while I tested the disaster recovery plan, I documented every line that I did, everything, how much time it took, which issues may rise during this specific step, and I documented everything with links, with diagrams to explain how the DRP looks like. After that, you have a disaster recovery documented, everything is perfect, you need to maintain the disaster recovery plan. I think this is the hardest part because DRP tends to break. That's what may happen because on your day-to-day, your application is using the main region environment, the DR region, nobody uses it. If someone eggs a new service, maybe he didn't apply the same CD process and he forgot this one. The Terraform code may not be updated on the DR side. It will break. So what we did to avoid from this issue, if you're focusing on the DR region, I added a different DNS that can reference, that gives us access to the DR environment. And I'm using an API testing tool that actually sends requests regularly. We are always running tests in front of the DR environment. And to make it work, since it's using a writable database, a read replica, sorry, not a writable, a read replica database. In the DR region, we have a read replica database. I added a new database, a writable one, only for the test. And I'm like coloring the request with the header, so the application will know to send the specific request to the writable database only for the test. So actually, I made the DR region environment to be functional also when I'm not activating the DRP. That's the thing, and I'm monitoring all this environment all the time with the Datadog. This is our observability tool. This what makes sure, that operation actually makes sure that when someone breaks the DRP, at the same day you will know about it, because without something that actually tests it, no way that it will stay functional when you really need it. So far, we talked about the disaster recovery plan, which is the answer for this is what you need to do when a big disaster happened. The region is not available because not always the cloud vendors has a huge disaster. Sometimes only some of the services goes down, not always all the region, which actually this is what happens most of the time. So you really need to think if you want to apply the DRP. The best thing you can do is not perform the DRP because it's a real mess, a lot of risks, because if you do it, you switch the database replica in our case. It's a mess to do it, so you should avoid from doing it. If you understand that only few services are down on your region, so try to understand if your system can keep functioning without the specific services. All the cloud vendors have few tools that can help you to build a resilience architecture, because as your architecture will be more resilient, then on the small incidents, you won't find yourself deciding to switch your region because something is not available. So on AWS, for example, you have the AWS Resilience Hub. This is a tool that scans your architecture and then scores you for the resilience. It may tell you on this database you forgot to apply multi-AZ, fix it, and then come back, you will get a better score. There's also AWS Fault Injection Simulator. This is actually a tool that helps you apply chaos engineering on your system. Chaos engineering approach is actually to see how your system reacts when you start to break things. Even in production, you can test it. For example, it may remove some of your Kubernetes nodes. Let's see what your Kubernetes cluster does when he loads nodes, how it affects. You can find real interesting issues only when you try things like that. And this is a really amazing way to actually apply it on your architecture. On Azure, a pretty new tool, very similar to the fault injection simulator, is the Azure Chaos Studio. From the few last months, they released this tool. And they also have the Azure Site Recovery and Microsoft Azure Backup. These are tools that helps you to actually manage all the disaster recovery plan aspects. On GCP, there's also a very similar tool, Google Cloud Backup and DR. And of course, there are many external tools, okay? Services that you can pay for to use, and some open source that can help you to apply the chaos engineering approach on your architecture. And also, there are a few code libraries. These are examples for .NET and for Spring Boot framework. On .NET, Poly is a pretty old library, but the chaos engineering approach is new there, and this is one of the best that I've seen. So if you have the resources in your company, so I would recommend to run like what this diagram shows. You have a steady state, then you need to have an hypothesis, you run the experiment, you verify the results, you improve, and then you run the experiment again. So if you can, once every month, you can, the team tries to see how the system reacts if you start to break it. This is an infinity process of improving the architecture. So few takeaways, because I want to make sure that you remember the right notes for the important things of what I said. Before you start, you don't need to deal with the technical part. First you need to go to the business needs, to talk about the ROI, return of investment, to decide about the strategy of the DRP, and you need to clean up the background noise that you don't want to be part of the DRP. Then, in the implementation step, as I showed with the CDN, you must know the limitations of your cloud service. Because if you are not reading enough the documentations, then you will create an architecture that actually won't work when you need it. Because when the region is down, that's pretty hard to simulate. So you really need to understand that you're doing the right things. No one is perfect. Your DRP will never be perfect, because then it's an infinity work. But the things that are not perfect, it's very important that you will document them in the execution plan. it's okay to do manual things and to leave things to do later, but just document everything. You need to be from now on in a DRP state of mind. I mean, it's not okay. Maybe you won't have the automated tests on the DR region as I showed you that we did. You need to understand that for now, every new service and every change you're doing in the infrastructure level, you must have in mind, how did I just broke my DRP? And as I said, you need to design the system like you don't have a DRP. Because if you always say, I can switch region, it will be okay, it's not good. Just think about every service that you're adding, how the system will respond if that service is not available. Not always possible to actually bring a solution for that, but try to think about it. And a DRP that is not being tested continuously, it means that you don't have a DRP. I heard about a company that they are actually testing their DRP on production every month. They prefer to have it when everyone is at the office, everyone knows that something is going on. They prefer to have incidents every month. They prefer that than when they need a DRP, it won't work. So they actually perform it every month. It's very inspiring, but not everyone can do it. But it's like to have in mind how it should be done. And from here, do what you can. So in the following links, you can scan the QR code. You can find all the resources that helped me to build this lecture. Many YouTube videos, articles, and also a link to the GitHub repository that I created with the code examples. And that's it. Hope you enjoyed.
Thank you very much. Great. We're going to do a Q&A session. We still have a little bit of time, so let's see if there are any questions. There's one here in the front. We're bringing you a microphone.
Hello. Thank you for your presentation. I would like to ask, how do you get notified about disasters? Do you automate it? Do you include it as part of your recovery plan?
How did I automate? What was it?
Notification about disaster happened. How do you know that you need to execute?
How do I know that a disaster happened? How do I decide to do it? So we had the option to actually rely on the DNS failover. This actually does it automatically because you can define on the DNS level endpoints that it can check, and then it realizes, okay, here the health check didn't pass, boom, it switched everything. But this would happen in an ideal world if we had the time to do it, because it can switch, but my DR is not ready. My DR environment is not ready, so I actually, because I have manual steps, I couldn't rely on this automatic way. So we are doing it with Datadog monitoring, which actually monitor all the infrastructure. And once there's an issue, it's actually, we talked about it as part of the RTO. It's part of the 20 minutes, because actually the manual actions takes me around, after I open my laptop, it takes me around 7 minutes. And if it's the middle of the night, I know that the on-call guy need to hear the phone and then to understand what happened. And it takes some time also to Datadog to notify PagerDuty that it needs to call. So we are receiving a phone call, then we understand that something is going on, and then we are apply it manually.
Thank you.
Okay, next question. Over there in the back.
Hello, thank you for the lecture. So basically my question is, as I know, almost every cloud vendor provides you with solutions with built-in solutions to build resilience, and why you decided to make like everything by your hand, to deploy to S3 buckets, etc., but not to use built-in stuff?
So I didn't hear everything. Like the end.
Okay, so
Yeah?
basically my question is why you decided to make everything by hands? So deploy, for example, manually to S3 buckets instead of using some built-in AWS solutions.
Yeah, so I used the built-in AWS solution where I could, but there are few services that you actually have to create manually on a separated region. For example, API gateway, it's a service. Behind the scenes, it's actually servers that are running, and you have to create them. Where I could use out-of-the-box solution, I prefer to use them. And maybe there are some out-of-the-box tools that I missed. I'm not saying that this is the perfect architecture. This is what works for us after I made the investigation. But maybe there are better solutions in some of the components. But absolutely, I agree that I would prefer to use built-in solutions of AWS if there are any better solutions.
Yeah, actually, I don't know about it because I'm more focused on Azure. And for example, for S3 buckets, storage account for Azure, they provide you with option to build in this resilience. For example, you can choose to spread your instances between different regions, different stacks of the data centers. So there are some options to use it, and seems also case studio. So yeah.
Well, yeah, on Azure, I know they have a totally different approach. So probably this architecture would be different if I was on Azure.
Thanks so
Absolutely.
much.
Yeah. Thank you.
Okay. Do you have another question? Over here in the front. Here, green shirt.
Yeah, hi. Could you please clarify these manual steps, why they exist, and what is actual difference between, because if we are using the cloud, for example, if we will put some load balancer in front, yeah, and just distribute, for example, I don't know the reason, 95% of load for, for example, for this agent and 5% of load for this agent, and have active architecture. Yeah, we should have active database because of that, and that could be technical challenge. But could you clarify difference in these? Approaches active, because it's not clear for me for the cloud case. What is the difference of cost?
Yeah, so you are asking actually to make it more clear about the difference between active architecture to the architecture that I just showed.
And also, you have some manual steps. Yeah, why they exist? What are these? Mm-hmm.
Yeah, so in active, you actually have a way to access both environments all the time, and both of them are fully operational all the time. It means that if you write something to the database on every environment, it will be replicated to a writable instance of the database which exists on both environments. So it's very far from what we have, because in the architecture that I showed, we actually have a writable database only on one of the regions, and the other one is just a read replica. It's not functional. The system on the DR region is not functional. It was really, we had to come up with another region. For example, we could upgrade to Aurora AWS Postgres, which gives a solution for, I didn't investigate about it too much, but they have a solution for the active to have two instances which are both writable. We could do it, and then to have an approach of active. But as I said, if we go back to the ROI, it doesn't work that in terms of how much money and time it would take us to do it. So we decided to stay with this one, 20 minutes, it works.
Yeah, but what about static stuff? For example, S3 buckets, you don't just use active in this case because we do not as I understand, do not pay any extra because we should pay some money to replicate database all the time. But if you have some static stuff, why don't just use?
The main reason that we don't want to have the active actually is it means that your DR environment will be always with full resources, which means that the Kubernetes cluster has all the time servers, very strong servers that need to be available, so you double the cost of your cloud all the time. It's very expensive. And what we did in the pilot light and more standby approach, as I said, you have a Kubernetes cluster, but with a T micro node, like the smallest node that AWS can provide, just so it will be alive. And then when I want it, I need to switch the nodes to much bigger nodes, so it will handle the traffic. This is one of the steps in the execution plan. After all, you need to make the environment much stronger, and this is what saves most of the money, because the environment exists, we pay for it. Database doesn't have a lot of data, just configurations, so very cheap to replicate it. We pay for the DR region, I think, $200 per month. It's almost for free.
Okay, thank you.
Thank you. We had another question over there. As a reminder, all questions get a little gift, and at the end, the speaker gets to pick the best question, and they get a bigger gift. So.
Hey, thanks for your talk. I have a question actually about disaster recovery plan. When it's not related to any specific region, but for example, you have a bug in your code, and in the same time, your Git repository, for example, Bitbucket or GitHub is down, and your pipelines are not working. How to ship a fix in this case? Have you thought about something like that?
Yeah, so this is a disaster. As I also said in the start, there are many disasters, and to this disaster we didn't prepare. We don't have a recovery for that, but from the top of my head, if GitHub is down, so I would build a local image and then push it with Argo Studio or something. But you need to think about it in advance and to have a doc that explains how to do it. Yeah.
Okay, thank you.
Thank you. Do we have another question? Okay, so I actually have a few questions for you. Did you get a chance to test your disaster recovery plan?
Yes, so as I said, I tested it, and actually I had the chance to test it on production because we had to create, because of the GDPR, a new customer from Europe came, and we didn't have a GDPR until that point, we didn't have a customer with GDPR compliance, so with these restrictions. So I had to create a new environment on the Europe region. And once I created that new environment, I also created a DR environment for that new environment. So I actually, this is exactly when I started to work on the DRP, and I had the chance to actually run the experiment on production, but without real traffic, so without being nervous, which was really nice. And that's when I did everything slow, and I could document everything, and that's my story.
So no stress.
Yeah.
Okay, nice. How many people here, raise your hand, have a disaster recovery process right now?
Nice.
Okay. That's interesting. Okay. If I don't want to create two CDNs because of the cost considerations, what are my options?
So the question is, if you don't want to have in advance two CDNs because of cost considerations, so there's actually another option, because as I said, you can't change the origin of the CDN after the disaster. So you create in advance two CDNs. So there is actually another option in the CDN. You can have actually also a feature to make the switch of origin automatically. not manually, and the automatically switch is an action that relies on the data plane and not the control plane. So this one will work, but this is an automatic step that, as I said, we gave up on few automatic steps. I know there's the option, but we decided to do a few things manually and not fully automated.
Okay, well, thank you very much. Please give a big round of applause for Yedidya.
Thank you.
Thank you.